Hi, my name is Isaac Eichmann, and today I will be explaining to you the designs and parts that went into the construction of the San Antonio Riverwalk and its flood control system, and why this is one of the most important engineering achievements of our time. To begin, construction started in March of 1939 under the direction of Robert Hugman. His idea was to create an extension channel and two flood diversion tunnels to eliminate any further possible flood disasters, such as the one that happened in 1921. Just to give you an idea of how massive this project was, 56 kilometers or 35 miles of river channels had to be widened, straightened, or deepened to allow construction to begin. The extension channel, you can think of this as the backbone of the flood control system. This is on the side of hydraulic or water resources civil engineering, but it bypassed the Horseshoe Bend in the San Antonio River, running about 15 feet or 4.87 meters deep along the channel. Also, when engineers constructed this, they had to clear lots of debris and use trenchers and drills to excavate the channel. As well, they established small concrete weirs in the bottom of the channels. These are just like miniature dams to encourage water flow and limit erosion. Also, two standard floodgates were implemented at point A and point B just to control how much water gets in and out of the Riverwalk that surrounds the downtown area. One of the major engineering technical achievements achieved in this process was the Tainter Gate design. It's located between point A and point B. It just controls the water levels within the Riverwalk. It's a pie-shaped structure that rotates when opening and closing. As you can see, there's a steel plate that's reinforced by concrete. The only forces required to lift it is a small electric motor connected to the wire cable, which really just directs the large upward force created by water rushing underneath the gate. And all it's needed to close the gate is the force of gravity. Also, you can see the two arms meet at the trunnion pin, which is really just the pivot point or where it rotates about. Also, you can see the small truss-like structure in the center for support. So, very efficient and stable structure. The two flood diversion tunnels, one was called the San Pedro Tunnel, goes about 2,000 meters in length, and the San Antonio one goes about 5,000 meters in length. This is on the side of structural or construction civil engineering. You can think of these as the arms and legs that transport all the excess water away from the city. Both have a diameter about 9.4 meters or 31 feet. Each feature two inlet shafts, two outlet shafts, three maintenance shafts, and five ventilation shafts. Excavation was completed by a tunnel boring machine, a very massive machine, but yet is really expensive but more efficient than the blasting and drilling method that's commonly used. However, when the civil engineers were excavating, they ran into a lot of rock fallout. So to combat this, they installed 60 40-foot or 12.2 meter rock bolts along the tunnels to hold the loosened rock together, acting as like hooks or anchors. Also, along the arch on the inside, they applied shotcrete and supportive ribs, and on the outside, triangular piers. This is a picture of the tunnel boring machine, really, really big. To conclude, I explained to you how this is an engineering wonder through all the solutions and problems that the engineers came up with and faced along the construction process. The system is modeled after across the globe. Sites include Oklahoma City and New York City have very similar riverwalks. However, still room for improvement. The engineers could have saved a lot of time and money if they had properly planned for the rock fallout beforehand.